Bismillahirrahmanirrahim. Today is a lecture of first lecture, linear momentum, and exercise 7a. I'm discussing two questions, 5 and 8. Question 5 says the rock of the mass 4 kilograms. So first of all, we must need a kilogram. If given in a grams, convert into kilograms. So 4 kilogram given here. Thrown upward with the initial speed 3. So it's thrown upward with a speed of 3. Okay, all right. And he says it's travel at a speed of 6 just before lands. So it goes down and lands here with a speed of 6. So this is 6. Okay. He says find the change in momentum. Okay. What is the basic formula of the momentum is mass into velocity. All of you familiar with the basic idea. Okay. So how to find change in momentum? So change in momentum, we can find mass. Okay, before, a very important thing I want to discuss with you, and that is when observer is here, when particle going like this observer, particle going away from you, speed is positive, and coming backwards, speed is negative. Okay. Now I can keep anywhere, observer down or up, so no issue. Okay. So I make it like, for example, this is an observer here. This is an observer. Okay. So observer is here, and let's see what is this speed is 3. This speed is 4. So sorry, 3, and this speed is I think given here 6. Okay. So once again, speed is 3 and 6. Okay. So change in momentum. So this is going away. So I can say that mass into velocity minus mass into velocity. Okay. Final velocity, we can, mass is given here 4, and velocity, because it is coming backwards, so not 6, minus 6. And this is going away, so 3. So answer is coming minus, we can say here minus 24, minus 12. So minus 36 Newton second. But we have to eliminate the negative sign, negative just for your ignorance. We're not important here. So ignore the sign. So we got a change in momentum. So change in momentum, you can see here is 36 Newton seconds. Okay, and units in Newton seconds you know very well. Okay. So this is a little bit tricky example we have. So let's see now how we can deal example number 8. Mass is given here 0.2 kg, okay, and it fall downwards, so ground starting from the rest. So let's say particles coming here downwards, okay, and it's hit here. So U is 0, it has U 0. And its height is given here 1.25 meters. Oh, and going downward, free fall, gravity is plus 10. And he said that the change in momentum is, in momentum is here, is 1.6 Newton seconds. Okay, so let's see now, it means bounce. So particle bounce up and it stops somewhere here. So particle stops here. So when it stops here, so last speed is confirmed 0, and this speed, and he says in the question number 8, he says that this is a height, find out the height. Our target is a find out the height. Okay. We can find out the height only possible if you know this speed, and that speed will help us to get this speed. So let's get this speed. So when free fall downwards. So free fall downwards. So when I talk about downwards, so let's say U is given here. So so 2AS equal to V squared minus U squared. Coming down, then S is 1.25. Last speed is my question. U is 0. So this is root of the whole thing. 2 times to 10 into 1.25. This is becoming 12.5 into 25. So this 5 meter per second. So it means this speed is a 5 meter per second. But do you know that we given this sentence. So let me write it. Change in momentum is what we have here. So just concentrate, please. Change in momentum, we have, you know that formula mv minus mu. Okay. Now, this is value is given here 1.6 Newton seconds. Okay. Mass is given here 0.2. Issue is only one here. Your observer is up or down. It is no matter, but let's see how we can deal it. Okay. Naturally, when it bounces up, the speed is here is smaller and this speed is bigger. And this change in momentum is a positive. So I'll start from here. So that is what? So mass into speed and minus mass into speed. Okay. This speed is returning speed. I repeat again. This u is the returning speed. Okay. All right. So here I'm getting what? 1.6. This is becoming 1. And 0.2 u. This goes there. 0.2 u comes negative 0.6 and u becomes negative 3. And negative 3 is speed here. Like negative is for because my eye is here. Observer is this one. Observer. Okay. So observer is this. So going this way, I took positive, coming backward, negative. That is why you got negative. This is coming backward. So what happens then while going upward? Now coming upward back. Okay. So what is it? This u minus eliminate 3. Last speed is going on the top 0. Gravity is negative 10. So find. So 2as equal to v square minus u square. Gravity is a negative 10. S is my target. Last speed is 0 and u is 3 square. So minus 9 by minus 20 and S becomes 0.45 meters. So this is a whole story and we can see here how I got the answer. I just explain again. Why I got this negative. Okay, some students say us here that why we can't take it, this is here and this here. No issue. For example, some students say, sir, final speed is, this could be. If you take this final speed and the initial speed, because this speed is smaller and this is bigger. So, you know, bigger, so smaller minus bigger, what happens then? It becomes negative. Then I have to take it here, change in momentum as a negative. Okay? But because it's given positive, so I took the bigger momentum minus the smaller momentum. Okay? And that is reason we got this negative 3. This negative shows that it is going back to observer. This minus representing that. So ignore the negative sign and that you got a u. And I think so the idea is very, very clear. And the question is over. Okay, this is another view I want to explain you that, for example, if observer is there, system is coming away, so speed is positive. And when going backward, so speed is negative, so I can keep it even here, negative u even, okay? And negative become plus, and then it comes answer positive, no need of sign even. So reason is what, as I explained there, you can see that one particle is coming away from you, is positive, coming backward to you, speed is negative. So this v is, why I put negative? Because coming back. And why is positive 3? Because going away. So that is why plus going away, because observer is here. And why is negative becoming going back? So this is the reason we can get this answer even. Issue is only here. So I think so concept is clear. That's it.